Here at 360, we're focused on solving the problems that cause you the most pain in your operation. And there's nothing like that moment of discovery when we know that we have the solution that's going to work best for you. I'm incredibly proud of the work the team has done here at 360, and I'd like to have some of them share with you the highlight moment when they knew that they had that solution.
I'm Jessie Kaiser. I'm a design engineer here at 360 Yield Center, and we are working on banding nitrogen on both sides of the row. The existing infrastructure, we'll be able to reach the target depth of 3/4 of an inch to an inch for banded nitrogen placement. We started work on this project just under 2 months ago. Since then, we've had 4 major design concepts, 10 to 20 iterations of each, and we've really narrowed down to the poly bracket on the closing system option. So by getting through this many iterations, we've been able to really look at some of the inherent problems of the system. The big ones include mud jamming. So if you hit a wet spot in the field, you're gonna have mud build up on the wheels. Another one is residue management, how residue interacts with the discs themselves and how those could create jams and issues as well. Then obviously, like I mentioned previously, the downforce issues that could arise as well due to the additional discs in the ground. So by looking at these issues through many iterations, we've really been able to narrow down and design around each of those individual problems. The coolest part about this project today is the fact that we can rapid prototype. For example, this product here, we took advantage of our plasma table. We're able to cut out pieces, weld them together, get very good prototypes. It'll help us to get a better representation of what an actual injection molded part will look like. So once we do go to our injection part, we'll be able to capture all of those features plus many others as well. That'll help this just be a really cool product.
My name's Noel Moore. We were challenged with trying to deliver liquid nitrogen to the field, to the planter, in a very efficient manner. When I was looking for inspiration for this, looked at what the Air Force uses to refill jet fuel on fighter jets in the air. They actually drop a funnel from the sky from a refueling jet, and then the fighter jet comes up and refills itself off of this funnel. But I actually turned towards the utility vehicle. A utility vehicle could be spaced on the same row spacing as your crop, and many farmers already have them available in the field. Although the Air Force had tackled the challenge of delivering fuel through a nozzle and funnel type system in the air, we knew that we had to prove this type of delivery system on the ground in real time. So using a nozzle with electromagnetics impregnated into the surface of the nozzle that turn on and automatically connect to a funnel was a possible solution for this means of connection and fluid delivery. The first time we took the nozzle out to the field and we turned our electromagnets on and were able to successfully and repeatedly complete that connection between the nozzle and the funnel, we knew that our engineering team had something to move forward with as a product to deliver the liquid fertilizer.
Hi, my name is Ryan Van Duzen, and I'm a design engineer here at 360 Yield Center. And over the last 18 months, I've been working on the Bullitt Ripper point. Greg and Tim came to me, and they said that we want to achieve a full soil profile fracture with a Ripper point. Now, the standard Ripper point's 8 inches, and we kind of started out way in left field with an 18-inch wide point. That 18-inch wide point, as you can imagine, was extremely hard to pull. And the quad track with 9 of these was struggling at its best to get it through the field. We had to start with increments of changing the width. We dropped down to 10 inches, went to 16, kind of did it all in progression. And finally we got that 14 inches, and that was the sweet spot width-wise, but that still didn't get us where we needed to be. So we started playing with the pitch, the roll, the yaw, and finally one of the angles kind of gave us that aha moment. So once we achieved the full fracture, we just had to work out the other fine details to get good wear and then to make sure that the tractor could pull it without a problem. And that's when we knew we were done with the Bullitt Ripper.